Hello, this is Mr. Miller. How you doing today? Tomorrow we have a quiz, and this video is a special video. It's covering the review for the quiz. It starts with basic derivatives, so let's get started. The first one is finding the derivative of y equals 9x squared minus 4x plus 12. So this is kind of old news for us. We know that y prime equals, we got to use the power rule. 2 times 9 is 18. It'll be x to the first power, or just x, minus the derivative of 4x, which is 4, and the derivative of 12 is 0. So we get y prime equals 18x minus 4. The second one, the derivative of cosine of x. Well, we just have to remember the derivative of cosine is minus the sine of x. Here we have 4 times the secant of x. So the derivative is going to be 4 times the derivative of whatever the derivative of secant is. Sorry, so 4 times the derivative of secant. So it'll be 4 times secant of x times tangent of x, since the derivative of secant is secant times tangent. All right, here we have 1 over x. Remember, view this as a x to the minus 1 as an example of the power rule. So we're going to multiply in front by the exponent. Y prime is going to be negative 1, and it'll be x to the minus 2. Okay, and then we can rewrite it as minus 1 over x squared. Same thing with this one. We can think of this as 6x to the negative 3. We haven't taken a derivative yet, we're just rewriting it. So now I'm going to take the derivative. Y prime would be negative 18. X to the 1 less power, so negative 3 minus 1 is negative 4. And we can rewrite this as negative 18 over x to the positive 4. Okay. This one, we can think of this as x to the 1/2 power. So y prime is going to equal 1/2 x to the minus 1/2, same as 1 over 2 square root of x. So remember, x to the minus 1/2 power, same as square root of x in the denominator. Okay, now we're going to move on to a couple trickier examples here. These involve the product rule or the quotient rule. So right here, this one would be f. That would be x to the 6, and this would be g. Remember, the product rule says do f prime g plus f g prime. So it's a little confusing here because the whole function is named f, but right here we're using f and g in the sense of the product rule. So far that really hasn't bothered anyone, which is good. So this is f prime of x equals, okay, so f prime would be derivative of x to the 6, which is 6x to the 5th, times g, which is tan x, plus f, which is x to the 6th, times the derivative of tangent, which is secant squared x. Now they want us to evaluate all of this at pi. So we have 6 pi to the 5th tangent pi plus pi to the 6th secant squared pi. Okay, tomorrow I'm only allowing you a scientific calculator. If you left it like that, I wouldn't be too upset. Tangent of pi is 0. Okay, and secant squared of pi is 1. So this term would just be gone. Secant squared is 1, so this would actually just be pi to the 6th if you worked on that. All right, we need the good old quotient rule. We haven't seen the quotient rule in a while. It's g f prime minus f g prime divided by g squared. Okay, that's the quotient rule. So remember, the numerator is f, the denominator is g. Here we go. So y prime would equal g, that's 7x plus 4, times f prime, that would be 4, minus f, which is 4x plus 7, times g prime, which is 7, all divided by g squared, 7x plus 4 squared. Okay, we should simplify it a little bit and see if we can do this quickly. 7x times 4 is 28x. 4x times 7 is minus 28x. Those cancel. And 4 times 4 is 16. And we have minus 7 times 7, which is 49, all over the denominator, 7x plus 4 squared. So I think we get minus 33 over 7x plus 4 squared. Okay, now moving on to the focus. Those were all review. So moving on to the focus problems, these involve the chain rule. So this one we can use the general power rule. We have a function raised to the 4th power. So y prime is going to equal the exponent times the function, whatever it is, to the 1 less power, times the derivative of the function, which is 3. So we get 12 times quantity 3x plus 11 to the 3rd. This one is one of the trig functions. The derivative of this would be y prime. Okay, that doesn't get any better. Y prime is secant squared of the function, which is 3x, times the derivative of the inside function, which is 3. So we get 3 secant squared of 3x. So the general power rule and those general rules for trig functions are very useful. All right, here are the next two. These also involve the general power rule. We have to view this as 2 times x to the 3rd minus 8 to the 1/2 power. Then we do 1/2, so y prime equals 1/2 the quantity inside the function to the 1 less power minus 1/2 times the derivative of what's inside. That would be 6x squared. The next step is to simplify. 1/2 times 6 is 3. We have the x squared. And this term to the negative 1/2, we're going to move to the denominator. So that's over the square root of 2x cubed minus 8. Hopefully you can see that there okay. All right, this one. Phew, this is getting tough. So we're going to view this as x squared plus 9 to the minus 6. So y prime equals negative 6, x squared plus 9 to the 1 less power, that would be negative 7, times the derivative of the inside function times 2x. So negative 6 times 2 is negative 12. We have the x. And we're going to put this guy in the denominator with a positive exponent. All right, we survived those. The next one is a combination of rules. When I look at this, I see right away that this is actually a product of things. X squared, which is nice, times kind of an ugly square root term. But we just got to kind of follow the product rule. So we have f prime g plus f g prime. Okay, so f prime would be 2x times g, which is square root of 9 minus 3x, plus f. Now, here's where it gets tricky. We got to think of this square root of 9 minus 3x as 9 minus 3x to the 1/2 power. All right, so where can I write that? Maybe, well, I'll just write out what we get. So we're going to get 1/2 times 9 minus 3x to the minus 1/2 times the derivative of inside, which is minus 3x. This is very similar to problem C above it. Okay, so when I got to taking the derivative of the part with the square root, I had to use the general power rule. I had to view this as 9 minus 3x to the 1/2 and take its derivative. Okay, so we get 2x square root of 9 minus 3x. Here we have minus 3x times x squared times 1/2. Wow, so we got minus 3/2. By the way, this shouldn't be 3x, this should just be minus 3. All right, sorry about that. So minus 3. So we get minus 3/2 x squared, and we can put this in the denominator, square root of 9 minus 3x. So what happened? Well, we were doing the product rule. It was going great until we got to the derivative of square root of 9 minus 3x, and that's what all this mess is. And so negative 3 over 2, that's the number part. We have an x squared, and that goes in the denominator. All right, it's a mess, I know. All right, now we're switching gears here, and we're moving on to implicit differentiation. So this one, we got to find the derivative, and then part B, we have to find an equation of a tangent line. So remember, we take the derivative with respect to x. So the derivative of x squared is 2x. For this next term, I need the product rule. This is f, and y is g. So it's f prime. F prime would be 3 times g, that's y, plus f, which is 3x, times g prime, which is y prime. So we needed the product rule there. Plus the derivative of y cubed, we need the power rule. 3y squared times y prime equals, the derivative of 8 is 0. Alright, so this term and this term, we got to move to the right side. We have to factor out y prime here. So I'm going to take care of all of that. We get 3x plus 3y squared y prime, right, equals negative 2x minus 3y. Then we have to divide by this quantity. So we get y prime equals minus 2x minus 3y all over 3x squared, or sorry, 3x plus 3y squared. Now, we have to evaluate this at 0, 2. So that's what this bar I'm drawing means. It means evaluate at 0, 2. So got to put 0 in for x and 2 in for y. So the numerator, that would give me negative 6. And in the denominator, that should give me 12. So altogether, I get minus a half. Man, I hope everything went right. So that's the slope at that point. Now we want to find the equation for the tangent line. So we do y minus y1 equals mx minus x1. Okay, so this is a y over here. All right, so if we just plug in, we get y minus 2. We want it at the point 0, 2 equals negative 1/2 x minus 0, which would just be y equals negative 1/2 x plus 2 if you simplify. Okay, we can do this. Now we're going to switch to a related rates problems. So this problem is a shape that's changing size. So we have a radius of a circle is changing at a rate of 4 inches per second. How fast is the area changing when the radius is 20? So we got to start with a formula. A equals pi times radius squared. We have to take its derivative with respect to time. So dA dt equals 2 pi r dr dt. We've used this formula many times. Okay, now I just have to plug in what we have. So we have 2 pi, r is 20, and dr dt is 4. So that'd be 80 times 2. I get 160 pi. And this would be, let me see, inches per second. Or sorry, inches squared per second is dA dt. Now, another question about dA dt. What rate is the area increasing when the circumference is 30 pi? So here we have our formula again. Problem is, we know the r dt, it's still 4, but we don't know r. So we got to figure out r. When the circumference is 30 pi, well, circumference is 2 pi times the radius. So if I divide by 2 pi, I get the radius is 15. Okay, and we have what we need here. So this is 2 pi times 15 times 4, which I believe is 120 pi. And again, inches squared per second. So sometimes you got to do a little work for one of the quantities you need. They don't give it to you directly. So if they give a circumference, I start looking for the formulas for circumference and see if that can tell me the area. Okay, getting there. We're making progress here. Moving on to the classic ladder problem. So we need the Pythagorean theorem for this. So in the figure, they named this side y and this side x, so we'll go with it. Y squared plus x squared equals the length of the ladder squared, 20 squared. And we take a derivative with respect to time. So 2y dy dt plus 2x dx dt equals the derivative of 20 squared, which is 0. That's just a constant. So there's our formula. We have to take a derivative of it. Now we're in the part where we plug things in. So, okay, so 2 times y. Well, what was y? The ladder was 12 feet from the ground. So we know y is 12. So 2 times 12. It's slipping at a constant rate of 2 feet per second. That's how fast it's slipping down the wall. So that's dy dt. And we're going to put -2 because it's decreasing. Y is getting smaller. All right, plus 2 times x. We don't know x, but we can figure it out by the Pythagorean theorem. So x squared would be 20 squared minus 12 squared. And if you do that, you figure out that x is 16. Okay, so we had to do the Pythagorean theorem. We had to figure that out. So this is 16. Finally, the x dt is what we're trying to find. Equals 0. So this is -48. If I move it to the other side, it becomes +48. So I get 32 dx dt equals 48. And then we end up with dx dt equals 3/2. I kind of ran out of room, but that would be feet per second. Okay, so kind of important here, this -2. Y is decreasing, so that has to be negative. X is increasing, so it should end up positive, and it did. All right, at the same instant, how fast is the area of the triangle changing? Well, here, once we come up with the formula, this is going to be easy. Okay, so we have A equals 1/2 x times y, base times height. In this problem, that's the area of a triangle. So if we take a derivative, it's 1/2 times what we get when we use the product rule here. So it would be the derivative of x, it would be dx dt y, or y dx dt, plus x dy dt. That came from the product rule. Now we just got to plug all this stuff in. So it's 1/2, y was 12, times, I messed this up. So I'll go 1/2 times the quantity. 12 times dx dt, we worked hard to figure out, is 3/2, plus x, which is 16, times dy dt, which is -2. This should end up giving us the dt, so we get 1/2. 12 times 3/2 is 18. 16 times 2 is -32. That looks like 14. I think I end up getting -7. All right, and that would be feet squared per second. So it turns out the triangle is getting smaller at this point in time. The derivative of the area is negative. Okay, so we're about ready here for the next one. It's 32. All right. Another Pythagorean theorem one. So it says a boy flies a kite which is 120 feet directly above his hand. Okay, if the wind carries the kite horizontally at a rate of 30 feet per minute, at what rate is the string being pulled out when the length of the string is 150? So here's the situation. The kite was here, right here was the kite, and it's being blown that way at 30 feet per minute. Okay, so we can think of this as A, B, and C for the Pythagorean theorem. And C is changing this time. It's not like the ladder problem. This 150 is changing. This 120 is staying constant, though. So we have the Pythagorean theorem, 120 squared. The reason why I'm not putting A in is it's going to stay 120. That height, vertical height's not changing. Plus B squared, that is changing, equals C squared. That's changing too. So when I take the derivative, this is 0. So that's going to be gone. We have 2B dB dt equals 2c dc dt. In fact, we can get rid of the 2's. Okay, let's plug in what we know. Do we know b? Oh, we got to do the Pythagorean theorem again. So if you do the Pythagorean theorem, I think you get b is 90. So b is 90. That would be the square root of 150 squared minus 120 squared. You know, that'd be nice. We're doing all this math. If they told us something. dB dt is 30. We know that. Equals c, it's 150 times dc dt. Okay, so if we divide by 150, this is what we get. dc dt equals 90 times 30 is 2700 over 150. Okay, I have a great feeling that reduces. So let me see, without a calculator here, that's 270 over 15. If we divide by 3, that's 90 over 5, which is, hey, 18. Wow. We get the CDT is 18, and that would be feet per second. Okay, so that's how fast this distance is changing. So if the wind blows a kite 30 feet per minute, then this is changing at 18 feet, I should have said, per minute. So if you were screaming there, I heard you. Units aren't seconds, they're minutes. So 18 feet per minute. All right, I'm going to take a break. I don't know about you. I highly recommend taking a break. Go get a drink, some popcorn. We got 2 stretch problems left when we come back. Okay, here we are, the final 2 problems. We have the old cone problem. So we're going to start by finding a relationship between H and R. So we're going to use the similar triangles here. So remember, R over 2 equals H divided by the total height here, H over 4. And if we cross multiply, we get 4R equals 2H. Or if we divide by 4, we get R is 2/4 H or 1/2 H. Now, so remember, once we find that relationship, we're going to plug into the volume formula for a cone, which is V equals 1/3 pi R squared H. So if we substitute in for R, we get V equals 1/3 pi R squared would be 1/2 H squared times H. So let me simplify this. We get V equals 1/3. That's going to be 1/4. So 1/3 times 1/4 is 1/12 pi H cubed. So we have to do some work to get our formula. Now we're going to take a derivative of that. So let me draw a little line here. We get dV dt equals 1/12 times pi times 3h squared dh dt. Okay, 3 times 1/12 is 1/4, so we get our final formula. dV dt equals 1/4 pi h squared dh dt. My goodness. All right, now they want to know dV dt when the height is 2.5 meters deep, and oh wait, they don't want dV dt. They give us dV dt. Water runs into a conical tank at a rate of 0.5 meters cubed per minute. So that's volume per time. I know that that's dV dt. So this is 0.5 equals 1/4 pi times h, which is 2.5 squared dh dt. Okay, now we can use a calculator. Actually, if I was using a calculator, I'd just simplify all this and do 0.5 divided by that. So I'm going to be a little lazy here and say this is equal to 0.5 over 1/4 pi 2.5 squared That's what the HDT is. And that would be, this problem, meters per minute. Now, you would just get some decimal when you do that, but I'm going to leave that for you. So the key is, for the cone problems, got to find a relationship between H and R using the similar triangles. Substitute in for R, and that's the formula we use to take the derivative of. Okay, it's in the stretch, but we can do this. We come to our last problem here. We want to find the derivative of this by using implicit differentiation. Okay, we got this. So we got to take the derivative with respect to x. And we got to show it that's equal to this mess right here. So the derivative of the first term would be 4y prime. Okay, minus, well, this is f and this is g. So the product rule says f prime g plus fg prime. So here we go. F prime would be minus 1, so this is going to be minus. G is y, so f prime g would just be minus y. Plus, we got f, which is minus x, times g prime, equals the derivative of 8, which is 0. Okay, now, got to solve for y prime. So the only term that moves the other side is this. So we get 4y minus x times y prime equals y. I don't know why my cursor is really blinking like that. Let's solve for y prime. So y prime equals y over, we have 4y minus x. Okay, that's that. All right, and it equals what it's supposed to equal. Now, these questions are kind of new, and this is in the stretch, but they kind of use our result from part A. It says, find the points on the curve where the line tangent to the curve has slope 1/4. Well, this is the equation for the slope of the tangent, so we got to set it equal to 1/4. Y divided by 4y minus x equals 1/4. Okay. So we have to cross multiply. 4 times y is 4y. 1 times 4y minus x is 4y minus x. If I subtract 4y from both sides, I get 0 equals minus x, or x equals 0. So we know that in order for it to have slope 1/4, x has to be 0. Now we have to go back to the original equation and figure out what y is when x equals 0. Okay, so we got 2y squared minus xy equals 8. If we put in x equals 0, this is gone. We used to have 2y squared is 8, or y squared equals 4, or y equals plus or minus 2. Okay, so there are 2 points, 0, 2, and 0, minus 2. Okay. Show that there are no points where the tangent is horizontal. If the tangent is horizontal, that means the derivative is 0. So let's set the derivative equal to 0. And we can always think of that as 0 over 1. So now if we cross multiply, we have y equals 0 times that, which is 0. Oh, wow. So in order for the derivative to be 0, y would have to be 0. But if we go back to the original equation and put in 0 for y and try to figure out x, we get 2 times 0 squared, which is 0, minus x times 0, which is 8. It's actually impossible because we get 0 equals 8. So there are no points where the curve is, the tangent is horizontal. That's what we're supposed to do, show that there are no points. There are none. Because y would have to be 0. There is no x value that makes y 0. So that's why. All right, the last one. Okay, super advanced. The very last question of the test is not a make or break part of the test. So if you get it, great. If not, don't feel bad about it. X and y are to be functions of time. So this is going back to like a related rates problem. All right, and it gives us dy dt. What's the value of dx dt? So we got to take the derivative of this equation, not with respect to x, but with respect to time. So this would be 4y dy dt. Okay, minus. We need the product rule here. So this is f, this is g. F prime would be minus 1 times g, so it would be minus, f prime would be minus dx dt. I almost screwed up there. I gotta remember, we're taking the derivative with respect to time. So f prime would be the derivative of minus x, which is minus dx dt, times g, which is y. Then we need f, which is minus x, times g prime, which is dy dt. So we did the product rule, equals the derivative 8, which is 0. So we're taking the derivative with respect to time. X and y both depend on time, like related rates problems. Now, we got to put in what we know. At time 6, y is 2. So where we have a y, we'll put 2. Dy dt is 3. And we want to know dx dt. Okay, so 4 times y be 4 times 2, which is 8, times dy dt is 3, minus, okay, dx dt, we're trying to figure that out, times y, which is 2, so minus 2 dx dt, minus x. Got a little problem here. I don't know what x is, so I'm going to leave it blank here, times dy dt, which is 2, equals 0. Okay, don't stay up all night trying to think about this. If you get it, great. If not, don't worry about it. So, problem is we need to know x. We know that y is 2, but we don't know x. So we have to go back to the equation and figure that out so we can put it in here. So, if y is 2, then we have 2 times y squared would be 2 times 4, minus x times 2, so minus 2x, equals 8. That's 8, so I get minus 2x equals 0, or x equals 0. Wow, that's 0. Now, we got to solve for dx dt. So we get 24 minus 2 dx dt equals 0. If you solve for that, you get dx dt equals 12. If everything went right. Alright, why would I ask that? Let's get a sample. That's like the worst of the AP test as far as implicit differentiation and related rates goes. But at least we kind of saw it here. So again, how does this go? Take the derivative with respect to time. Just like related rates. That's our formula. Take the derivative with respect to time. Put in what we know. And sometimes we have to find something. We didn't know x. I had to figure out that it's 0. And then I solve for dx dt. Okay. This is not going to make or break you. It's the last part just for fun on the quiz. Wow. We did it all. Good luck tomorrow.